All right, in this lesson, we're going to talk about systems of equations, and we're going to be using the elimination method with multiplication. This is very similar to elimination with addition subtraction, but now we're just changing the operation that we're going to be using. So let's take a look at the first system we have here. It says determine the solution to the system by elimination. And if we take a look at the first equation, we can see, well, actually, if we look at both of them, we can see that the coefficients of the x are going to be different. They're not going to be that similar that we talked about in the last section. Same thing with the y. You can see that I have a 3 and a -1, and those are not similar coefficients. And what I mean by similar is a number like 3 and -3, or 4 and 4, or 4 and -4. We have totally different numbers as our coefficients. So with the elimination method with multiplication, what we want to do is we want to make those coefficients the same. So if we, there's a couple of different ways we could do this, but I'm just going to kind of show you one and maybe talk about the others. So in this example, let's go ahead and work with the x's. Now, the x's, we have a coefficient of -1 and 3, and I want to make them the same number. So to make them the same number, I could multiply the top equation by 3. Or I could even multiply it by -3, and if I multiply by -3, it would give me the exact same coefficient. So it doesn't matter what you multiply it by, whether it be 3 or -3. Watch what it's going to do now. I'm going to take that first equation and I'm going to rewrite it down underneath, and I'm going to distribute that 3 into everything here. So I have -3x plus 9y is equal to 30. Okay, so that is from my first equation. Now I'm going to take that second equation and I'm just going to rewrite it right underneath my first equation. Okay. Now, hopefully you see that now our x's are similar, so we're able to eliminate them. So I'm going to eliminate them by adding, using the elimination method, adding, subtracting, and they eliminate. So then I have 9y plus -1, that's going to give me positive 8y, and then 30 plus 2 is going to give me 32. And don't forget to circle this operation out here just so you don't forget to use that whenever you're working vertically in these operations. Okay, so now what we're going to do is go ahead and divide both sides by 8. And that's going to give me y is equal to 4. All right, just like before, I have a solution. So my y is going to be 4. And I have to go back and I have to figure out what my x is. Now, this is kind of a unique thing because not only do I want to take that y equals 4 and substitute it either back into the first or second equation that I started with, but I could also plug it into that third equation that I created by multiplying the first by 3. Doesn't matter what you substitute it back into, no matter what, you will still get the same x value. Personally, I think that the second equation is the easiest to substitute it back into, so I'm just going to go ahead and do that. I always like to do the one that looks the easiest to my eye. Okay. So I'm left with 3x is equal to 6, and I'm just going to quickly divide that by 3, and then my x will be 2. All right, so the solution to my system here is going to be the coordinate 2, 4. So what that tells us is that there is one solution to the system, meaning there is one intersection point between the two linear equations, which would give me a consistent system. And since there's only one solution and there's not many solutions, it's also going to be an independent solution. Okay, let's try another one now. All right. So I'm going to look at my x's and just going to kind of scan it over with my eyes and notice that, well, my x's are not similar and the coefficients of my y's are not similar either. Now, I could either work with my x's or I could work with my y's. It doesn't really matter. No matter what, you're going to get to the same solution. So personally, I don't know, maybe we worked with the x's before, so let's go ahead and work with the y's now. You can see that I have -2y and then I have -4y. And you can see that I could easily make that -2 into a 4 or -4. So what I'm going to do is I'm going to multiply the top equation by 2. I could also multiply it by -2. It doesn't really matter. And I'm going to rewrite it down here. Negative 8x minus 4y is equal to 4. Now I'm going to rewrite that second equation. I didn't do anything to it. I didn't multiply it or anything, so I'm just going to rewrite it as is. And then I'm going to simplify it. Here I need to figure out, well, what do I want to do? Do I want to add it or do I want to subtract it? So if I'm looking just at my y's, negative 4 minus negative 4 is going to give me that 0 and eliminate it, which is basically what I want. So I'm going to use that minus as my operation. So I'm going to move back to my x's here. Negative 8x minus negative 12x. Isn't that really adding 12x? So that'll give me 4x. And then 4 minus 8, that's going to give me negative 4. I'm going to go ahead and divide it by that 4 so that I can solve for my x value, which is going to be negative 1. So I have an x value of negative 1 for my solution, and I need to go back and figure out what is my y. So again, I could put it back into the original 2 equations, or I could even put it into that third one. It doesn't really matter. It'll work for all of them. It looks to me like the first equation might be the easiest, so I'm going to go ahead and stick with that. So I'm going to say negative 4 times negative 1 minus 2y is equal to 2. And I'm simply just going to go ahead and solve it. I'm sorry, I'm running out of room here. I'm going to move it in a second. Okay, I'm going to move my work right up here. So now I have negative 2y is equal to negative 2. And that's going to divide, and y will equal 1. All right, so my solution is going to be negative 1, 1, which is going to be 2 intersecting lines. And they're going to intersect at one point. So this is going to make this one a consistent and an independent system of equations. And just as a note, I know we use this method because basically that's the lesson today, is using the elimination method with multiplication. But if you wanted to, you could take both of these systems, transfer their equations into slope-intercept form, and put them on a coordinate plane by graphing, and you will still get the exact same answer as you have here. So I'm just showing you different methods on how to do the exact same thing. Okay, now we're going to kind of bump it up just slightly. Let's take a look at this first one. All right, if we take a look at our x's, we can see that we have a 3 and we have a negative 2. And in our y's, we have negative 6 and negative 5. Hopefully you notice that I can't multiply one of the equations, and get a number that is consistent between the two. So, or get that number, that coefficient, to be the same. Because a 3 and a negative 2, well, I can't multiply 3 by anything to get negative 2, and I can't multiply 2 to get 3. It doesn't work. But what I can do is I can multiply both of the equations to get a common number. So what I mean by that common number is, if you look at just the x values in this one, I have 3 and negative 2. I could multiply the 3 by 2 to give me 6. And the second equation, I could multiply the negative 2 by 3 to give me negative 6. So sometimes you have to multiply both equations by a number. So I'm going to go ahead and do that. I'm going to work with the x's. You could work with the y's if you prefer, but I'm going to go ahead and work with the x's here. I'm going to multiply the top equation by 2. If I do that, 2 times 3 is going to give me 6. So I'm going to go ahead and do that right here at the bottom. I'm just going to go ahead and simplify it out. So I have 6x minus 12y is equal to negative 24. That's my first equation. Now I need to get my x coefficient in my second equation to be 6 as well. And the way I'm going to do that is I'm going to multiply it by 3. I could also multiply by negative 3 if I wanted that negative 6. Or if I wanted that positive, you know what I mean. But in this case, what I want to make it a negative 6. You'll see why in a second. I'm going to say negative 6x minus 15y is equal to negative 3. So that 6 I could have made positive, and then I would subtract them. But in this case, it doesn't really matter. All that it's really going to determine is this symbol or this operation right here. And in my case, I'm going to add. If you multiplied it by negative 3, you would end up subtracting. So I'm going to go ahead, and now that I've made that coefficient the same, I can go ahead and add them together. So there, my elimination method worked. So if I continue this, I'm going to get negative 27y equals negative 27. And I'm going to simply go ahead and divide that by negative 27, and I'm going to get y equals 1. So in my solution, I'm going to have a y that's 1, and I need to go figure out my x. Now, I could go ahead and I could substitute it back into the first, the second, or now even the third or the fourth equation. It doesn't matter. No matter what, I will get the same answer. I'm just going to stick with the first equation. So I'm going to say 3x minus 6 times 1 is equal to negative 12. And I'm just going to go ahead and simplify this down. And divide by 3 to give me that x is equal to negative 2. All right, so there's the solution to my system. This is a consistent and independent system. I know many of these are, but I'm just trying to show you, different examples. We're going to have some here that are going to give us some no solutions and infinitely many solutions in a moment. All right, let's take a look at this next one. We could look at the x's or we could look at the y's. It doesn't really matter. I want to, since we worked with the x's before, let's go ahead and work with the y's now. We have a 4, we have a negative 6, and we want to figure out what is the number that I'm going to create both of these and make these into. So personally, I think 12 is a great number to put these both into. So if I multiply the top by 3, that's going to give me a y of 12. So let's go ahead and simplify that out. Great. Okay. The second one, if I want to get 12, I could multiply this by 2 or negative 2. It doesn't really matter. Let's go ahead and multiply it by 2. I like sticking with positives personally. So let's go ahead and do that. So now I have 10x minus 12y is equal to 16. Alrighty. I've made my y's the same. Now all I need to do is figure out which operation I want to use. And I have positive 12. I'm going to go ahead and add negative 12 to it because that will be what eliminates it. All right, so if I work with my y's now, negative 18 plus 10, that's going to give me negative 8x. And 0 plus 16, that's going to give me positive 16. So I'm going to go ahead and finish that off. My x will give me negative 2. All right. Let's go find my y. I could put it into the first, second, third, or fourth. It doesn't matter. I think I'm going to stick with the second equation. I think that one looks nice. So 5 times negative 2 minus 6y is equal to 8. So I have negative 10 minus 6y is equal to 8. Simplify that down. And I'm going to actually move my work up here. Negative 6y is equal to 18. Y is equal to negative 3. Alrighty, and there's the solution to my system. And it's consistent, and it is independent. Okay, let's go ahead and take a look at 2 more here today. Yep, just 2 more. All right. So if we look at this first one, I want to kind of focus on looking at my x coefficients and my y coefficients. And you can see that I've got some big numbers to work with here. I've got 6 and I've got 15. It looks like the number that I could create as my coefficient would probably be 30. Yeah, 30 would probably be it. And I think if I worked with my y's, I would probably have to create 50 as my coefficient for both of my y's. So it's up to you, whatever you'd like to do. I guess I'll stick with the x's for this one. Okay, so let's go ahead and make the x's the same, the x coefficients. I'm going to multiply the top equation by 5. When I do that, that's going to give me negative 30x minus 50x equals 10. And if I want to make that bottom coefficient the same or similar, I'm going to multiply it by 2. So that's going to give me negative 30x. You can see that my x's are going to eliminate. And then I have negative 50y. Oh, I'm sorry, I wrote an x up here. That's a y, my bad. Is equal to 10. Oh, this is an interesting one. Do you notice that the first equation is identical to the second equation? So we have a special kind of answer for this one, but let's go ahead and continue the problem just to kind of show you how to work the whole thing. All right, I'm going to go ahead and I'm going to simplify this out. So it looks like I'm going to be using subtraction. Negative 30 minus negative 30, that's going to eliminate. Negative 50 minus negative 50, that's going to eliminate. Then that's going to give me 0. Equals 10 minus 10, that's going to give me 0. If you remember when we talked about this earlier, we talked about if those two numbers are identical or if it's a true statement, then that creates a system that is going to be represented by IMS, or infinitely many solutions. So what it means is these two lines are actually an identical line. They're one line right on top of the other, which makes this a consistent system because it has a solution, but because there's many solutions, this is going to be a dependent system. Okay, let's try one more. I bet you can guess what this one's going to look like. Now we could work with our x's here, we could work with our y's. You know, the more you work with these, the better you're going to get at them. So I personally think that we could make the x's 12. So let's go ahead and do that. I'm going to multiply the top by 4, and that's going to give me 12. So if I do that, let's go ahead and say negative 12x. I'm going to multiply 4 times 15, which is going to give me positive 60y, and that's going to equal negative 8. Okay, I'm trying to make my x's 12, so I'm going to multiply the bottom one by 3. All right, that's going to give me 12x minus 60y is equal to 12. Okay, let's go ahead and do some elimination now. Negative 12, I'm going to do addition here. Negative 12x plus 12x, that's going to eliminate. Oh, this is interesting. 60y plus negative 60y, that's 0 as well. So that's going to give me a 0 on the left. And now we have negative 8 plus 12, which is going to give me a 4. Obviously, this is not a true statement. So if this is not true, that is going to give me a solution of, well, no solution. Now, if you really wanted to double check yourself, you could turn both of those equations into slope-intercept form and graph them on a coordinate plane. And both of these should give you parallel lines, which we know do not intersect. Another way you could do it is, you know, just at the very beginning of the problem, you could put them both into slope-intercept form, and you'll notice that you have the same slope but a different y-intercept, which again will tell you that you have parallel lines. And we learned that from Unit 4 and 5, so that should be very familiar to you. So that is the end of the section on elimination with multiplication. Very similar to the process of elimination with addition, but now we're just multiplying. Sometimes you multiply one equation, sometimes you multiply both. It just depends on the situation.